All right, as you guys are preparing naturally for your Calculus 1 final exams, or your AP Calculus AB midterms, or your AP Calculus BC midterms, you will naturally be trying to practice with differentiation methods. One of these is called implicit differentiation. So what is this? Well, normally if you're told y equals 5x squared, and you're told find dy dx, it's pretty straightforward. All you have to do is take the derivative of this function. So y prime equals 2, and you drop the power down, and you subtract by 1. So y equals 2 times 5x to the first power, or y prime equals to 10x. But what if you're given a slightly more complicated function? For example, 5y squared equals to 2x cubed minus 5y. And you're told find dy dx. This is where implicit differentiation comes handy. Okay? So the issue with this is we could theoretically solve for y, but it would be messy. And then finding the derivative would be even messier. With implicit differentiation, we can find dy dx in terms of both x and y. So all we have to do, there's one new thing to do actually. There's 2 steps. So step 1 is to derive both sides. However, when deriving y, you have to write dy dx. And then step 2, solve for dy dx. So let's use those steps on this problem. So we have 5y squared equals 2x cubed minus 5y. Derive both sides. So the left side, derivative of 5y squared. This is a constant times a variable raised to a power. So move the power to the front, 2 times 5y, and we drop the power by 1. 2 minus 1 equals to 1. So 2 times 5y to the first power. And now we have to write next to it, since we took the derivative of a y term, dy dx. Now let's do the other side. Derivative of 2x cubed, that is 3 times x, drop the power, squared. Since we took the derivative of x, we don't need to write dy dx. Now let's take the derivative of this next term, negative 5y. Derivative of a constant times variable is simply the constant, minus 5. Since there's a y there, we write down dy dx. Now we just have to solve for dy dx. So let's just simplify this down. 10y dy dx equals to 3x squared minus 5 dy dx. So let's move this to the other side. So 10y dy dx. In order to move negative 5 dy dx to the right side, we just add negative 5 dy dx to both sides. So plus 5 dy dx. And now we do equals to 3x squared. Okay. Now what do we have to do here? Well, we need to solve for dy dx. So this whole thing can be simplified down into dy dx times 10y plus 5 equals to 3x squared. Now, to solve for dy dx, divide both sides by this term. So dy dx is going to be equal to 3x squared divided by 10y plus 5. And that's our answer right there. let's go over some more problems. 5x cubed equals to negative 3xy plus 2. Well, we have x and y. What do we do there? Well, we have to use the product rule. So, first let's take the derivative of the left side. So derivative of 5x cubed is simply 15x squared. Now to derive the next term on the right side, negative 3xy. So product rule, derivative of the first times the second plus derivative of the second times the first. So derivative of the first, derivative of negative 3x. That's just negative 3 times the second, that's y. Now we've got to add plus the derivative of the second times the first. So derivative of y is 1, but we have to write dy dx times the first, that's negative 3x. And now we have to derive the next term too, so that's just plus 0. Now we solve for dy dx. So 15x squared, I'm going to add 3y to the other side. 15x squared plus 3y is going to be equal to dy dx times negative 3x. Divide both sides by negative 3x. 15x squared plus 3y divided by negative 3x is equal to dy dx. And that's our answer right there. Let's do one more problem. 2x cubed is equal to 3xy plus 1 squared. And we have to find dy dx. So the way I would personally approach this is by changing this so we have the exponent on the smaller term. So if we take the square root of both sides, then we can do square root of 2x cubed is going to be equal to 3xy plus 1. Now we find dy dx. So the derivative of the square root of 2x cubed is it's chain rule. So let's just rewrite this as 2x cubed to the 1/2 power is going to be equal to 3xy plus 1. So let's derive the left side. Drop the power into the front and drop the power by 1. That's the derivative of the outside. So 2x cubed times 1/2. And then we're going to multiply that, or we're going to raise that to the power of negative 1/2. And now we multiply that by the derivative of the inside. Derivative of 2x cubed is simply 6x squared. And that's the left side done. Now let's do the right side. Derivative of 3xy plus 1. So 3xy, that's going to be product rule. Derivative of the first with the second. So derivative of 3x is 3 times y. Plus the derivative of the second with the first. Derivative of y is 1 dy dx. With the first, so times 3x. Derivative of 1 is 0. Now let's just solve for dy dx. So let's just rewrite this as 1 over 2 times the square root of 2x cubed times 6x squared equal to 3y plus 3x dy dx. So let's subtract 3y from both sides. So now we have, and I'm going to combine this together, 6x squared divided by 2 square root of 2x cubed minus 3y is going to be equal to 3x dy dx. Divide both sides by 3x. And then we find dy dx. So dy dx is simply just equal to 6x squared divided by 2 times the square root of 2x cubed minus 3y divided by 3x. And that is our answer. If you have any questions, let me know. And I will be posting another video as well shortly using trig implicit differentiation. So look out for that.